Filament runout sensors. Yep, we're going again. Hello everyone, Chris here, and yes, we're going to take yet another run at filament runout. And I've done a lot of videos in the past about filament runout sensors, but they were mostly focused on either Octoprint or Marlin firmware. With Marlin, on most boards, it should be fairly straightforward to get your sensor up and running, and you'll be good to go. But I do get a lot of questions on other types of firmware, mainly RepRap and Clipper. Now today we're going to be mainly focused on RepRap, because I have had my own challenges getting a consistent filament runout sensor to work. And Duet most commonly ran RepRap firmware. There was a while there where you really didn't see RepRap run on any other boards. And there's a sensor that they manufactured. Actually, they came up with a couple of different types, but one that I've always found really interesting. And that's this rotating magnet filament monitor right here. It doesn't just sense filament runout, it should also be able to detect jams and to see if your filament is skipping. If you take a look at the diagram, basically we have a hobbed assembly, a magnet, and a sensor. It comes with a PCB that actually has firmware loaded on it, so it does have some smarts to it. As the filament goes past that hobbed gear, the magnet should be able to tell the sensor if that filament is still moving or not. So at this point, you're probably thinking this is just another video where I show you how to set up this filament monitor on your 3D printer and then you'll be good to go. And you're not completely wrong, but there's two things about this sensor that make it somewhat interesting. The first one being, I paid $53 US for this kit. It doesn't even come assembled, you have to print your own housing. And two, every review that I've ever read for this sensor, most people had an issue getting it set up or never got it working at all. And there's one thing about this hobby and making content that I really enjoy, and that's the problem solving. If I can figure this sensor out, how to get it set up and show somebody else, if they already have this sensor after they've paid this much money for it, that should be really helpful for at least a few folks. Also, this will get us started successfully configuring a filament runout sensor or monitor in RepRap firmware. You can take tidbits from this config and use it on your own. So it's a win-win. Now let's get started with the sensor. We do have to put it together. We'll do that, I'll show you how it works, and then hopefully we can move to the config and get it installed. So let's see what we're working with. So here's everything that came in the kit. Basically we have a PCB here. Like I said before, you can actually flash firmware on these if they have an update. But mainly it's just so that we can use the sensor on here to detect that magnet is moving. Then we have our hob gear assembly here. It does have a magnet on the end. That's what makes it trigger. A handful of screws, a spring, our idler where that spring pushes up against it, a bearing for the other side of that gear, a handful of pins, some connectors, and some of these collet clips so you can use some PTFE to put it all together. So pretty basic all in all. I will mention they call this the version 2. It actually says version 1.7b on it, but if you see in the documentation, you want to go with the parts for version 2. And for your printed housing, this is going to hold your idler, that hobbed gear. This is going to hold your PCB, and then your idler sets in these two printed parts. You set it inside here. It's pretty easy to assemble. Now for my housing, I did use PETG. You do want to make sure there's no strings in that filament path to interrupt that sensor. That could cause you a lot of headaches, but it's a pretty easy print overall. It really doesn't have to be black. You can use whatever color you want, probably whatever plastic you want. But for the assembly, first, we're just going to take our little idler printed pieces here. I did use 3 outer layers so that those pins would be solid. We'll take our idler gear, put it on one side, and then encapsulate it with the other part. And that's our idler assembly. That sets down in this printed piece right here. Just like that. And then your spring goes in here. The spring is pretty low tension. It should be pretty easy to put it inside there. Just like that. So the spring will keep that idler pushing up against the filament. Again, your filament path is right here. Then we'll take our flange bearing and we're going to seat it on the other side of that hobbed gear. You want the flange towards the gear, just like that. And then we can put it in our housing with that flange bearing going towards the housing. You want this sticking out the top. Make sure that flange bearing is seated on the other side. And then your top lid printed part will go right over that hobbed gear assembly. And then your PCB has a single hole over here, lines up with this hole in the housing. Just sets over it right like this. The fit should be nice and snug. The shorter screw looks to be an M3x6. Goes in the single hole. Actually, they appear to be M2.5. And then the two longer ones go through these back holes all the way through both sides of the housing. And that's all there is to the assembly. I would suggest you check it with a piece of filament to make sure everything is running smoothly. My housing is just a little bit tight, but we can work that out. After a quick test, you can go ahead and put your collets in. They should fit right in the plastic housing on both sides. And now you're ready to use whatever PTFE tube you want to install that sensor. Now, as far as wiring these up, I will go over how these connect to the board. But the pins you have up here on the top, this side is ground, and then you have a switch wire. Over here you have your output. This is your output pin. This is 3.3 volts, and this is ground. This is the stock configuration. It does operate on 3.3 volts, just like a Duet board would. Now, you can let these operate at 5 volts. If you really have to, you can take this pad over here, scratch out the center so they're not connected any longer, and it'll operate at 5 volts. Be careful when doing that. For today, we're just going to go with 3.3, and that should work on a lot of boards. Just make sure which voltage your board is running at before you try to run the sensor in one mode or the other. You don't want to use it at 3.3 volt if your board is running at 5. Note that the switch connections here are optional. You can use it for a switch trigger. In this video, we're just going to be concerned with the pins over here because we want to use the monitor and use it as a filament runout with that hob gear, this whole assembly as it was intended. But you do have that option if you wish to use it. And to test this sensor, we're going to be using my 2020 cube here. This is the printer we built a couple years ago. It uses exo slides, but it does run a Duet Wi-Fi 2 and the expansion board. And this is the board that they probably intended you to use this sensor on, so it should be a good fit. If we have a chance of getting this thing running correctly, it would be on this one. Also, this printer runs a Hemera extruder, and it's very important for this sensor to work to be very close to the input or output of your filament. The flex in the filament could cause issues and cause this sensor to read incorrectly. So hopefully this is the best case scenario to get this sensor set up and working. Now let's move to the hardware portion, get it cabled up, see where it lives on the board. And like I said before, we've got the E3D Hemera on here, so that should make our physical install somewhat straightforward. I'm just going to put a piece of short PTFE tube here, because the top of this, by default on the Hemera, it has a collet clip it'll go down into. Now I am going to go ahead and put this retainer on the sensor side, because you don't want that PTFE tube moving with the retractions. That could cause issues, cause it to trigger falsely. But with it in there, just like that, you should be able to set it on top of the Hemera and push it down in there if you have your tube long enough, and it's not going to go anywhere. And then from there on the top, you can just use another short piece to lock it in place, and then feed your filament in however you wish. Now we need to set up some wires so we can connect it to our board. Now on the Duet boards, you should be able to connect it to any of the in-stop wires you wish. On the Duet 2 Wi-Fi, there is an E0 and E1 stop set that we're going to use, so we're just going to go with E0, and that's these 3 pins right here. So now we need to make a cable for our sensor. Now on these Duet boards, they use a Molex KK. There's a look at the pin. I like to use this style of crimper. I just think it's a little easier to do than the other style. This one has the ratcheting jaw that will actually hold the pin for you while you try to load the wire. I'm using a 24 gauge wire, so I'm using the 1.9 millimeter setting. And you should be able to just slide the wire in. Make sure that insulation is down around the end of the pin so that it can crimp it on. And just make sure where you strip the insulation off the wire is in the upper collar here and the insulation is down the lower. You don't want to get that insulation up too high. That could cause some connection problems. And on the board side for that cable, you've got the retaining clip where it goes right here. That goes up on the board. We're doing signal, 3.3, and ground. So it goes on E0 right there. And for the sensor side, it's flip-flop. Again, the retainer up here on the top, it goes like this, ground, VCC, and then our signal wire. Goes on the sensor, just like that. So that's pretty much all of the hardware setup. Now we need to make the firmware work. As always, Duet has a lot of great information out here on the web on everything they do, but for this filament sensor, we're going to use M591. Now there are some differences in between RepRap firmware versions. You can see it all laid out right here. I am on 3.2.2, but pretty much 3.2, 3.3, and 3.4, they're going to be really close to the same. It's just how it's going to interpret the filament error G-code. You can run a macro when that filament sensor changes state. In the older versions, it's just going to pause the print. It doesn't support that filament error macro. So again, the version of RepRap that we're going to use, all it does is pause the print first and then it runs filament error.g. But we'll get all that set up. And they have an example out here of exactly what we want to do. We're just going to copy this line, but note all these different configurations. You can pick which sensor you have. If you have a simple sensor, just a switch, the Duet laser style, or the rotating magnet style. Also, they have an option to use with that micro switch. If you want to add that micro switch on there to just sense when it runs out, you can do that as well. But option 3 is for us, and I'm sure that we're going to have to add a few additional parameters described down here, but let's just start with the basic line. So in our sysconfig.g, I'm just going to put it down here close to the bottom. We'll just paste in that example, and I'll just leave a comment. So that should get us off and running. So let's go ahead and save, and we'll test it out. And right into the testing, I ran into a problem. I didn't even get through the prime line before it hit filament runout. Now, I tested this many times with many different housings that I tried to create to get this whole thing to work. But it always came back to one problem. So the housing that Duet created, you can see a spot I put on the magnet sensor there. The housing they created doesn't confine the filament quite enough. And I do believe that these were designed to SLA print, so you could get just a little bit higher resolution. You'd have a higher tolerance, but it appears it doesn't work very well with FDM. If you move the filament and you watch that gear, you can actually see that it doesn't always turn that gear efficiently. Some of these that I tried worked better than others. This one appears that it's not working at all. But again, I ran through many of these trying to figure out how to make it turn successfully. You can get in there and clean it out. You can lower the resolution on the print, but none of them worked all that well. And this is the error that you would get on the Duet screen when you hit that filament runout. It's going to pause the print and say the filament moved too little. So the sensor basically thinks it's jammed. So after many attempts to try to make the stock housing work, even reworking the stock housing, I was somewhat successful, but it would still always pause. And like any good 3D printing user, the next thing you do is Google it. But a lot of times when I have an issue, the first place I go is the Duet Forums. Duet Forums have a lot of great information, not just with Duet products, and a lot of the people over there are very friendly and willing to help. So I always scroll through that. And being this is a Duet sensor, that is the first place I went. And the community to the rescue as usual. And I found this post by Duet Forums user Lo-Fi. And big thank you to this user. They saved this whole thing. So this is the stock housing when he started working on it, making some changes. If you scroll through here, all the different iterations that he made, and he ended up with a great design that just seems to work. Now remember, there are two versions of this sensor, a version 1 and a version 2. The version 1 has a lot less thick magnet on top than version 2, so if you print out one of these housings, you're going to need the correct version. And Lo-Fi has posted all of that over here on GitHub, including all of his print specifications. I will leave a link to all this in the description. And here's a look at the new housing that Lo-Fi created. It's got a lot tighter tolerances. He does recommend you print this FDM at a 0.1 layer height, 20% infill. I did use PETG, and remember, use the correct version. But it assembles pretty much exactly like the stock sensor. So you have new reworked pieces that hold your idler bearing. He does recommend you glue these. I haven't had any problems just letting them float in there. Again, I haven't tested for thousands of hours, but for all the testing that I've done, it works just fine without gluing them, but consider that. It does have a new indent to hold that spring a lot better on here and the housing, but it just sets in here. And the spring will slide in right behind it. That already fits a lot better. It stays in place. And the gear magnet goes up. It just slides into the housing. Just push it down a little, make sure that bearing with the flange seats in there correctly. And then the new cover piece goes on top. It fits right over these arms. Now, he designed this to use servo screws that are actually threaded, but it's easy just to drill all of these out. I drilled them out to 2mm and used the stock 2.5mm hardware. I did leave this one as a servo self-threaded just because I had a couple of screws laying around. I didn't have any long enough for these, but again, drilling them out, it works just fine with stock hardware. The PCB sets right in there like this, and then we can put our screws on. PCBs in, you have the same spots you would on the stock housing for some collets. One on the upside, one on the downside. You can slide your PTFE in. And then put your clips on to lock it in place. And it's going to go right back on the printer, just like the stock setup. So I just kicked off the test print so that we can check the operation of the filament sensor. I did move the sensor up here to the top corner. We'll take a look at it here in just a second. That's just so that I could film the operation of it a little bit easier. You might want to keep it pretty close to the extruder. Depending on your extruder setup, everything's going to be pretty much custom. But if you have a lot of retractions, if you need to do large retractions, that might fool the sensor into thinking it's stopped or going the wrong direction, so be careful with long retracts for sure. But let's jump into the DWC so that I can show you some troubleshooting steps and what the sensor looks like when it's operating normally. Now, while the printer's going, you can check the status of the filament sensor. Just go into console and you can do an M591. And you have to call it by the sensor index. Ours was D0. It's going to give you some information about how much filament has passed and the parameters that it's going to use to detect that filament. You have a minimum, a maximum, and you can adjust all of these in the firmware if you wish, if your sensor isn't working quite right. If you need to, there are calibration steps on the Duet site. You can follow these. It's pretty straightforward. Remember your troubleshooting LED. There's an LED on the side of the sensor that flashes and codes. This will give you an idea of what's going on if you're having a problem with your sensor. Here's a look at that LED of what it looks like when it's operating correctly. When it's not printing, it flashes red and green back and forth. That's normal mode. That's how you know it's ready to go, it's operating correctly. And then here's all the parameters you can use for that 591 if you need to adjust it. P3, that's the rotating magnet sensor. Your extruder drive, like I said, the index number for that extruder, we're using D0. There are special parameters for that laser filament sensor if you have one of those instead of the magnet one. And then for the magnet one, really the only one you need to look at is L. Here you can adjust the filament movement per complete rotation if there might be an issue. Most of the time you're not going to have to mess with it at all. You might also want to consider making some macros for this setup, like filament load and filament unload. Now remember, you can use the filament error G-code, the .g file, to do things when the filament sensor gets triggered. You can do a few different operations now in the newer versions of RepRap, but I really didn't see any good use case for the Hemera that I had set up. I really don't need it to automatically back out the filament because it's a relatively short path. But if you had something like a BMG and you had a sensor that was really consistent, you got your setup just right, that might be the way to go. Put your G-code in that filament error.g. Here, I just wanted a simple load and unload macro. It's just a couple of commands. For load, I just switched to relative mode for the extruder, so I could tell it how much I wanted to extrude, and I just pulled it in 75 millimeters. I'll show you that here in a second. And for unload, really the only thing that I'm worried about is the ramming sequence. It's a lot easier to use the filament if it has a nice sharp point on it. So I ram it 5 millimeters quickly and then pull it out 100 to make sure it's out of the Hemera so that I can pull it back through easily. That point will make it come out of that filament sensor housing a lot smoother. So making macros and RepRap in the DWC, that's one of the handiest things that it does. So definitely consider doing that. And like I said, I went ahead and mounted my sensor up here just so I could show you things a little bit easier. But let's just go ahead and give it a snip so we can test our run out. Our filament is now past the wheel. It's no longer rotating successfully. The sensor automatically triggers a pause.g, and that is set up just in the text file in the system. You can change the position wherever you want. Mine is just in the front left, so we're at a pause. The DWC is going to say printing paused, so you can close this and then do whatever you like. Now again, on my setup, I stay up to temp on the hot end and the bed. You could set that differently in your filament error.g or your resume, however you want to do it, but this works best for me with the Hemera. So all I'm going to do now is use my unload macro. You just click it here. You can put these on the front screen too if you'd like, so you don't have to come into the macro screen. But I'm just going to hit yes. And as you saw in that G-code, it's going to ram it and then back it out 100 millimeters. It would be better if the Hemera could actually back it out a little bit more so you could get it past this top piece of PTFE, but you should be able to just go ahead and pull it out. I like to cut a nice sharp tip on the filament, and then we should be able to just load it back in relatively easily past this sensor. And then back down in the Hemera. And with those load and unload scripts, I just push it down in there until it starts meeting the gears. You can kind of see it go through the tube, but just right to the top there. The Hemera is nice because it does have an idler door you can use to load, but if you have the script, you don't need to. So I'm just going to hit my load macro. It's going to pull it in. It's going to extrude 100 millimeters relatively quickly. You can see it priming down there. I'll pull that out. And from the status screen, you can just hit resume print. And we're right back to printing where we left off. A successful filament detection. So there it is, the Duet Magnetic Filament Runout Sensor. Now, I'm not suggesting you run out and buy one of these for your setup. It's relatively expensive and it's hard to get set up and working correctly. Again, a huge thank you to everyone at Duet Forums and the user Lo-Fi for reworking this housing. That is the only way that I got this set up and working. But this is more a video for somebody that might already have one of these sensors. But I think there's a lot better solution out there that probably costs a lot less money, but maybe you already have one of these and you never got it working correctly. This might help you out. And I have always wanted to try one to see how it worked in the first place. So hopefully someone finds this helpful. That will be it for today, and I'll see you very soon on the next one.